Today we're starting a brand new module, Module 5. So if you look in your workbooks, you'll see that you have all brand new problem sets in there. And we're starting, of course, with Module 5, Lesson 1. And your learning goal today, it says, I can explore volume by building with and counting unit cubes. What I passed out to you is a bag of unit cubes. Now these are math tools. They're not Legos and they're not toys, so we're going to be using them and treating them like math tools. And you guys are doing the perfect thing right now by just keeping them where they are. We don't need them yet. So before we dive in, or while we dive into today's lesson, we got to first talk about how we can measure things. So one way we can measure things is measuring the distance. And distance is the amount of space between 2 points. So I can find the distance between me and Grishma on the floor. I'm 1 point and Grishma is another point. If we find the line, if we make a straight line between me and her, we can find the distance between me and her. Do you agree? We can also find the distance between room 50 and the office. Room 50 would be a point, and the office is another point. If I make a straight line between here and the office, can we find the distance? Yeah. Okay, so we measure distance using regular, I put regular in there, units, because it's just a line, right? Okay, so an example of some units we might use is 1 foot, or 1 FT is the abbreviation. Do you agree? Another way we can measure things is by talking about its area. And an area is the amount of space a flat or two-dimensional figure takes up. Okay, so we use square units to measure area because think about it. If I want to measure the area of this room, of the carpet, if I just put down lines, would I be able to find out how big it is? How many dimensions are there in the floor? 2, right? There's a length and a width. So you need to use square units to measure the area. If I want to find the area of this screen right here, and if I drew lines like this, would that help me find the area? Would that help me find the area? No. But if I drew squares like this, could I find the area? Could I fill up the entire area of this page? Could I? So that's why to measure area we use square units instead of regular units. Lines won't measure 2D spaces. You need 2 dimensions, a length and a width, to measure area. Okay? So again, we use square units. An example of that could be a square inch. A square inch would be a square where one side is 1 inch, the length is 1 inch, and the length is 1 inch. And so this box right here is what we call a square inch. Does that make sense? If the measurement from here wasn't 1 inch, but instead it was 1 yard, and this one was 1 yard, what do we call this? A square yard. Very good. What you just did was you built a 3-dimensional figure. It has a length, a width, and a height. Do you agree? Okay. And so to measure the amount of space a 3D figure takes up, we use volume. Okay, volume measures the amount of space a 3-dimensional figure takes up. So think about it. If we used a line to measure distance, and we use square units to measure area, could I use a square unit like this to measure how much space a 3D figure takes up? No, right? It's just flat. So I need a 3-dimensional figure, or a unit, or a cubic unit, to measure volume. Okay, so what you have here, your 1 block, this is a cubic unit. Okay, if it's 1 centimeter by 1 centimeter by 1 centimeter, that means it's a cubic centimeter, and this is how you write it in shorthand. Okay, so if this is 1 centimeter, and the width is also 1 centimeter, and the height is also 1 centimeter, we call that a cubic centimeter, and that's what we use to measure volume. Even though these 3 figures look very different, they have something in common. They all have the same volume of what? 8 what? Cubic centimeters. Good. And we could write that out using words like this. 8 cubic centimeters. Of course, this would become 8. Or if I want to write it in shorthand, I could write 8 centimeters, and you draw a small 3 there. If it's a big 3, it's not cubic. Okay? In order to help us use dot paper to help us draw the 3D figures we build, I'm first just going to show you how to draw 1 cube. Don't you agree that this, when we get to the end, step 3 right here, it looks like a 3D cube? Okay, here's how you do it. You don't start by drawing a square. You connect 4 dots to make a parallelogram. Okay, so this will, like this. This will represent one face of the cube viewed at an angle. Again, you should not be drawing yet at this time. You should be looking. Then, when you have that, remember this is my original parallelogram. Then you draw 3 straight segments going from one dot to the next to represent those 3 edges. See how that works? Okay. Then for step 3, remember we started with our parallelogram. We drew our 3 straight segments from the top 2 vertices. Vertices are the corners, and the one on the bottom right. And then you finish it off by connecting to draw the missing segments, and then you'll have a cube. We can also draw cubes that are connected together, much like the structures you built that have 8 cubic centimeters. So what you do is you first connect. If you want to draw cubes that are stuck together, eyes up here first, watch first before you try drawing. You're going to first draw 2 parallelograms that share a side. Do you see how those 2 parallelograms share a side? Okay. Then, so basically you start the same. You draw your first parallelogram and you draw another one. But be careful, they're sharing an edge right here, so you only have to draw that line once. Do you see that? Okay. Then, this time you have more vertices to connect. You're going to do all your kind of horizontal lines. And then finally, after you've done that step, which are these 4 lines, and you have your parallelograms, you draw the 3 segments that connect the missing edges. Okay? So what I want you to do right now is you're going to look at your figure that has a volume of 8 cubic centimeters, and you're going to figure out together with your partner how you're going to draw that on the dot paper.